Hi, welcome to our video on power. In today's lesson, we will be learning about power, which is related to work. This lesson comes right after our work lecture. So let's get started. So, what you need to know by the end of this lesson is what power is and how to solve for power. This is broken down into needing to know the formula, the units, and how to calculate for power. So let's get started. What is power? Power is the rate at which work is done. So, in order to know what power is, we need to know two things. First, we need to know work. If you don't remember what work is a force applied to an object that makes it move. We learned about this in our previous lesson. So it is a force applied to an object that needs to make it move. Our second requirement is time. How long it takes to do that work. So, again, power is the rate at which work is done, and that requires knowing the work and the time done on that work. So, now that we know what work is, let's take a look at some examples. We got two examples here. A guy climbing a cliff of a mountain and a hiker climbing up a mountain. So let's first take a look at the guy climbing the mountain. As this rock climber climbs up the side of the cliff, he is elevating his body at a few meters at a slow rate. So he is going slowly. Therefore, even though he is doing a lot of work, the amount of time it takes him to do this work, he has very little power. So he has very little power because it's taking him a long time to do this work. However, on the other hand, the trail hiker elevates his body up the same amount of meters in a shorter period of time than the rock climber. So, since it takes him less time, even though they are doing the same amount of work, he has a higher power level than the rock climber because he's going at a faster rate. So, between these two pictures, the rock climber has less power than the trail hiker. Because even though they have the same amount of work, the rock climber is taking a longer time to do it. So, now that we have a firm grasp on what power is, we can now start beginning to solve. In order to solve for power, we need to know two things. First, we need to know the formula, and then the units. So, let's get the formula first. The formula for power is found by dividing the work done on the object by the amount of time it took to do that work. So, this formula is written as power equals work divided by time. This can be shortened to power equals W divided by T. And as you can see, it is denoted as a lowercase t, and that is important. Time is always written as a lowercase t. So, now that we got our formula, we can get working on our units. The units for power combine the units for work and time. Our units for work, as you remember, is the joules, and our unit for time is seconds. So, the unit for power equals joules divided by seconds, or this is more commonly known as watts. Now, we always usually write watts because there's no real nice way to shorten it. And it is a very short word to begin with. So, you have sometimes have heard of the term horsepower, and have probably wondered what that means. Now, it's kind of related to power, but horsepower refers to the work done by machines. it is only referring to machine work. So, 1 unit of horsepower equals 750 watts. Now, you really don't need to know this for the exam, but this is a good bit of information if you are curious about it. So, now that we got our units and our formula for power, we can now solve for power. So, at this point, you need to make sure you have a calculator so you can follow along. So, let's get started. If a swimmer, let's take a look at our question. If a swimmer does 3,654 joules of work in 65 seconds, what is the swimmer's power output? Now that we got our question, we can now start looking at our problem. So, first thing we need to do is draw the box. Now that we got our box drawn, we can move on to our second step, which is to write our givens. Since our givens are power, work, and time, we are going to write that in our givens box. Our third step is to determine your givens from the problem. This will require us to look at the problem again, so let's take a look. So, our work is 3,654 joules, and I've highlighted that in red in our question. So since we know our work is 3,654 joules, I'm going to plug that in to the work spot in our given box. So now it's time to find our next unit. Our next unit is time. Our time is 65 seconds according to our question. I've highlighted that in blue in our question, and I've plugged that into our time spot in the given box. Our last given is our power. Now, since we don't know what our power is, since the question is asking what is the swimmer's power, we are going to put a question mark there. Now that we know all three of our givens, we can now write our formula. Remember, our formula is power equals work divided by time. So, now that we got this information, and now that we got our formula, let's rewrite our formula in our work box, so that way it will make it easier for us to substitute in our work, which is our next step. Step 6 is to substitute our givens. So, power stays the same because we don't know what that is. So, power equals our work, which is 3,654 joules, divided by our time, which is 65 seconds. So now that we got our information, we are going to solve a problem, which is 7. So in order to solve, we need to divide 3,654 joules by 65 seconds. Now you can do this longhand or in a calculator. I chose to do it in a calculator, and I got an answer of 56.23. So power equals 56.23. Now that we got our answer, we can bring down our answer, which is step 8. So now that we got our answer brought down, we need to attach our unit. Now our unit is watts, so we are going to attach watts to the end of 56.23. So the swimmer's power was 56.23 watts. So now that we've solved our question, we now know how to solve for power. So we've now learned what power is, how to solve for power using the formula and our units, and we've calculated for it. So now that you know what power is, we are ready to learn more in class. If you have any more questions, feel free to watch this video again or ask me questions in class. Thank you and have a nice night.